All right, good morning, everyone. Welcome back. My name is Salim Ali. I'll be moderating this session. And this session is really meant to provide an interface for industry and government as drivers of demand to some degree, to address one of the questions that was posed to us in the prospectus for the conference, you may recall, was to assist companies and countries in identifying resource insecurities and develop strategies to improve the resilience of critical material supply. So in order to do that, we're going to look at the relationships that are being established between the public and the private sector and how innovation is part of this very important equation. In this regard, we will also address one of the questions that was raised earlier on around the role of innovation and research and development. I should perhaps preface the introductions by saying that I'm an environmental planner by training, and so I tend to have a very ecological lens at the metal supply arena. I became interested in this field from the perspective of environmental and social conflicts around mining. And we had the conversation earlier about the situation in Malaysia. In 2012, when I was directing a center in Australia on social responsibility in mining at the University of Queensland, where I retain affiliation now as well, but I'm moving back to the US, and I'll tell you a little bit more about the context there, which connects here. I was asked by the Malaysian government then to advise them on a blueprint they were working on for their green economy. And as part of their green economy blueprint, they had the rare earths facility in Kuantan, the processing facility, as a signature project. And of course, because Linus was an Australian company, they were very interested in engaging with the Australian institutions. So lo and behold, I found myself in Kuantan amidst a torrent of hate mail that I was getting from activists saying, how dare you, academic, go in and support this kind of an effort? And I said, look, I'm just going in as an academic trying to understand this situation better. It was a fascinating journey for me trying to understand this sector better. I had my roots in chemistry. My earlier degrees were in chemistry. Then I went into environmental planning. So my first love was always the periodic table. And there I was, again, embracing the periodic table in all its vagaries. And so that's how I became involved. And I have followed the social and environmental dimensions of this whole dynamic and the role of government. Subsequently, I visited the mines in Bayonobo in China, the rare earth facilities, became more involved also with some of the small-scale mining, which was addressed as well in areas like in southern China particularly. So now, given that preface, let's think about what is the role of government and private sector in this whole demand context. And we're going to really have with us a panel that can take us into the depth of this. We're very fortunate to have both a government research institution represented, a major international company represented, and also an industry analysis and intelligence firm represented at the panel. So without further ado, I would like to go directly into our panel. I'm not going to give you detailed bios because they are already in your portfolio. We're going to go directly into the panel itself, and I'll come back to the connection I was going to make with my US affiliation later. So I think there's a very interesting story there which will connect with David's first slide. And so hold that thought, and I'll keep you in suspense till later about that. Now, I'm going to actually change the order a bit because we don't want to test the German internet too much. We hope that they will stay stable. And so we're fortunate to have with us, of course, Reinhold Schindler, who is the Director of Purchasing and based with Siemens. They have a purchasing council for magnets and rare earths. And unfortunately, he couldn't make it in person. He was planning to, but thankfully, we're able to have him online. So Reinhold, please If you could present 5 to 7 minutes of comments, and then we'll move on to the next panelist.
Okay, thank you for having the opportunity to share this important topic with you and to discuss the challenges we are facing currently, in the past, and I guess also in the future with this important material field, rare earths, rare elements. So I would like to share my desktop with you to give you a brief overview to how we see this, this material field. Safe harbor statement. So just to give you some bullet points, how does our company assess future demand for materials and because we have numerous applications. So the next topic is how will the growth of magnets affect rare metal resources market? Then I would like to have a closer look together with you on the lessons learned from the growing demand for magnetic material that can be extrapolated for the growth of other high-tech components. And last but not least, what impact on the supply market is to be expected from recycling? Just to get started with the first topic. We experienced in the very beginning, when we faced that rare earth could become an issue, it was roughly in 2011 when we had that hype, unexpected hype from China. So we were looking at, we have so many products, we have so many components, where do we see the rare earth? So, and one lesson learned was that we had to adjust our corporate coding system, that we can finally, today we can do that, find these critical elements in our hundreds of million byparts. This requires that we have an active participation in product lifecycle management. We are from the very beginning involved in the ideas of our technology guys. Cross-functional projects are supporting that. An important topic to become more serious of this elements is to build up technology know-how. We experienced that in 2011, nobody was really aware of the elements from the table. We were, so to say, overwhelmed. We designed that in, and now we had to find solution how to handle that, to replace that, or finally how to get rid of the problems. And to be honest, at that time, it was a very hard time for the R&D guys because everybody blamed on them. They said, hey, you must have known that these elements are critical. Why did you use this in your application? And why did you cause that bottleneck for our companies? So this led to the bundling on and coordinating strategic commodities on company level. So this means magnets and rare earth is a topic at corporate. This is not handled at the business unit itself or at the divisions. It's guided from the top. As already mentioned, early involvement of all cross-functional departments is essential. We've heard before that it might be difficult to identify critical raw materials. So therefore, we used a tablet distributed from the European Commission, and you can find here the different heavy rare earth elements in. So in daily business, to be honest, we feel confirmed that these elements were critical, are critical, and will remain critical. So you can see it's tungsten, it's niobium for the superconductive wires, it's light rare earths. So it's really that bunch of material that concerns us a little bit. Just to give you a brief overview, this is our product lifecycle management process. Starts from the planning, from the
see, I told you the German internet. Yes. No, it should come back. Let's try. Can we
Reset.
reset? Okay, while we're waiting for the connection to come back, may I maybe just take on from Reinhold in terms of their notion of criticality? Perhaps can we have the context from Japan? How do you see criticality, and how does the government research organization plan ahead for that kind of criticality?
Well, there are many aspects to set the criticality, I guess, and the biggest problem may be how the element is distributed in the world, and that is the main concern, I guess. And
so the geopolitics is the
yes,
main concern in terms of where the metals are located. I should note, of course, that Dr. Yutaka Tai is the Director of Materials Technology with the New Energy and Industrial Technology Development Organization, NIDO, which is under the very powerful Japanese ministry, MITI, which we all know quite well. So thank you.
Thank you. Okay, first of all, I'd like to express my gratitude to Sasakawa Peace Foundation and APARC for giving me a chance to talk in this excellent conference and in front of excellent audience. I am from NIDO. It's as he introduced under the supervision of Ministry of Trade and Economy. And we have been surveying medium and long-term strategy for the rare metals and their substitute materials from the year 2005. And based on the survey, we have been conducting research projects for the reduction and the substitution of rare metals with high risks from 2007. So I will talk about the demand drivers of rare metals.
Could you move your microphone a little bit higher, please?
Okay.
There, thanks.
Is that okay? Sorry. So I will talk about the demand drivers of rare metals based on the survey. The demands for the rare metals have naturally been driven by the new products based on the innovative technologies and industrial development in the world. Looking into the timeline, the elements such as tungsten are used for the cutting tool, and indium are used for the transparent electrode for the flat panel display were positioned in the elements to be substituted with the priority in the beginning of the survey, of our survey. But in the recent years, technologies relating to the energy saving and environmental protection become more important. In particular, efforts to reduce the global warming must be accelerated worldwide. By this reason, in the latest survey, we paid attention, special attention to the permanent magnet motors and secondary batteries and catalysts for automotive emission control and light emitting diodes. A similar survey done in the US emphasized the demand for the solar battery and phosphorus. Okay, in the second part, I will briefly go through each technology, but not getting into technological details. Concerning electric motor, the half of the electricity in Japan is consumed in the electrical motors. It's a very big demand. Motors based on the high-performance magnets are indispensable for the electric and the hybrid vehicles, so the demands for the motors will steadily increase. Currently, almost all the high-performance magnets used for the vehicles are fabricated only in Japan, so the permanent magnet motors are especially important for us in that sense. Well, in terms of rare metal, expensive heavy rare earth elements such as dysprosium and terbium needed to keep the high performance of the neodymium iron boron magnets at high temperature where they are exposed in the vehicles. Potential substitutes such as samarium iron nitrogen and iron nickel alloy with a special crystal structure have been proposed. Well, let us step to the batteries. Lithium-ion batteries are used in a vast number of products. Among them, the electric and hybrid vehicles are quite important for carbon abatement. Concerning the electric vehicles, Nido and Nissan Motor Company and the Kanematsu Corporation have just started this month's demonstration project aiming to increase the distance traveled by electric vehicles in the metropolitan area here in California. The project is conducted under the cooperation with the state of California. The secondary batteries are also key devices for establishing a smart grid community. In 2011, we experienced a catastrophic earthquake that caused a shortage of electricity for a long time because of the disruption of a nuclear power plant. After that, movement toward networking various power sources has been accelerated. In terms of materials, transition metals such as cobalt, nickel, and manganese and graphite are the main ingredient in the lithium-ion batteries as well as lithium. In the beginning, expensive cobalt was used in the positive electrode, but now the materials shifted to the nickel and manganese, so the recycling merit has been lowered. Graphite is used for the negative electrode. 70% of graphite is produced in China, so we should keep paying attention to it. Lithium-ion batteries still needs to be improved, especially in terms of its energy density. Accordingly, the studies on the different type of batteries, such as those with high lithium density, are now under progress. Okay, now I move on to the catalyst. There may be a controversy if automotive catalysts will continue to drive demands of rare metals. However, we consider that the number of combustion engine cars will grow in developing countries, so at least in the short time range, conventional cars will increase the demand of the rare metals. In addition, hybrid and plug-in hybrid vehicles are installed with internal combustion engines, so these automobiles needs catalytic converters as well. For automotive catalysts, you know that our platinum group metals, namely platinum, palladium, rhodium, are used since they are produced in South Africa and Russia. So the supply is affected by the social or other instabilities in these countries. In terms of substitution, it is very difficult to substitute platinum group metals with using other metals. And the practical approach to reduce the usage of platinum group metals in the catalyst is to extend their lifetime by several different approaches. And as for platinum, future rise of a number of polymer electrode fuel cells may increase the demands. And finally, let me introduce a little bit about the collaborative research project between the US and Japan on the rare earth element. In 2013 to 14, we assessed the potential collaboration for neodymium magnet recycling between the US and Japan. In Japan, we have techniques to recover a rare earth element from a wasted magnet. So we assessed the feasibility of the recycling path where end-of-life products in the US are shipped to Japan and processed to metals. The result of the project suggested that the bilateral recycling can reduce the carbon dioxide emission for production of metals, but it is not feasible in terms of production cost. This is because more than 90% of the cost is a labor cost for dismantling motors. Thus, the dismantling process must be replaced by an automated process. Currently, the automated magnetic recovery is now under research in Japan and the Critical Metals Institute in the US, where we have agreement of a MOU with NEDO. I hope such collaboration will take a role for the resource security in both nations. Thank you.
Thank you very much, Dr. Tai. So in terms of one of the points that's really important to make is that the international cooperation around these elements, it's not just an issue of conflict, which we do know about in terms of the World Trade Organization case, but there are opportunities for collaboration, as is indicative from the Japan-US relationship, and clearly that is very important for Sasakawa's efforts as well. And the point that you mentioned of the relationship you have between the Japanese car manufacturers and the government in having a research that is driven by both environmental regulations in some cases, like catalytic converters clearly are for environmental pollution control, and you are actually driving a certain metal demand out of a pollution control technology. And so this is all very important for us to keep in perspective. Now we'll go back to Reinhold. Happily, he is back online. So sorry about that.
Sorry, the network was interrupted. I had to dial in again. So
okay.
question,
No problem.
shall I set up with the slides, or shall I? I don't know how far you got the messages.
Yes, I think if you could try to capture maybe your what we call the elevator pitch, you know, and I'm sure Siemens makes very good elevators too, so you can do that quite
Okay,
well.
so I will do it very quickly.
Okay.
I will do it very quickly.
Very good. Yep. And if you do want to show a quick slide, I think it's okay.
So. So can you see my screen?
Yes. Yep. Very good.
Oh,
We're
that's
seeing
good.
the last slide right now, but we are.
Yeah, sure. So, okay, in quick. So where shall I set up? From the very beginning?
No, I think maybe if you can just go, sort of go to the key take-home messages. In terms of if we go to that question that you were, you know, how is Siemens particularly assessing future demand scenarios? I think that would be a key question for us.
Okay, so I have to start with that slide here. We have an internal corporate coding system where I can find the elements and where I can find the products where these elements are in. So, for example, the neodymium iron boron magnets, if I am looking for neodymium, I can see all products that we buy with the content of neodymium. So finally, for the current business already established, I get it out from our SAP system. And together with our sales department, we are doing prognoses, updates, quarterly, monthly, depending on the final product. And this gives us a very clear picture for the next 18 months. And we do also a long-term prognosis according to the ramp-up schedule from sales department for the next up to 5 years. It's a different story with the products which are not ready for supply, which are in the planning phase. Here we have start with a product life cycle management. We start from the very beginning. We are planning the product. We are planning the product portfolio with the product manager. We define the elements for the product. We discuss the critical elements like rare earth or tungsten, all that stuff, and we evaluate the supply risk for that and the dependencies at that stage. Because if we identify a risk, we immediately set up a risk mitigation plan to somehow to reduce that risk with the rare earths, with very critical elements. Just to give you an example, and very critical to us is lutetium for the PET scanners at healthcare. We do a kind of stockpiling here because this is very, very sensitive. If there is no supply, there will be no scanner in the market. So we do not want to take this risk. Therefore, we stockpile the material in-house. Then one picture, if you see a wind turbine and if it's a 3 megawatt direct drive turbine, the magnet content is 2 tons. So whenever you get a news we installed a new wind farm with so many gigawatts, and this is offshore, you can calculate which demand in magnets is built in the generators. So we believe the rare earth market is still and will stay dominated by China. Heavy rare earth will stay a bottleneck because the prices are down. Nobody is really willing to invest. And we are really happy that from that 200 mines, junior mines that we see or that we saw in 2011, 2012 as new projects, that there are still 10 which look like that they could survive, but nobody knows. So requirement to us, no dependencies, traceability of rare earth metals from mine to metal, and we build up alliances and collaborations along the supply chain. This is what Jeff Bedford, you know that we had that collaboration with you and the Japanese magnet maker along this supply chain to establish an independent supply chain for magnets outside of China. So regarding the demand, and here thanks to IMCOA, Curtin University, Australia, they are regularly updating these numbers. As of today, you can see the total rare earth production is roughly the demand is roughly at 160,000 tons. And on the right hand, you can see the market share for the catalysts, glass polishing, and so on. And just to refer to the magnets, the share of magnets is at 32%. If we look forward to 2020, you can see the demand will go up to 210,000 tons expected. And the magnet share with the elements will roughly stay at 35%. So this is not a big rise in percentage, but it's a big rise in demand. And you might say now, oh, wonderful, there is plenty of rare earth in China, there is plenty of rare earth available. It doesn't look like this because illegal mining is still a big topic we are facing, and we take this very serious. You can see here on the right hand, if you take the numbers in 2013, roughly the illegal material in the market was 25%. And even if the Chinese government is officially fighting against the illegal mining, there is an increase to be expected in illegal mining. It will double from 25 to 50% in 2020. So we can discuss, does the Chinese government really take this illegal mining so serious, or what is the power in that market that allows this high share?
Just quickly, may I interject to ask, how do they come up with that number, projection of illegal mining? Being a bit of a data dog, I always get worried about projection.
So as of today, and I attended the Bautu Rare Earth Conference last July, the forecast is, the forecast is somehow a result of the demand in the market and the production. And if you talk today with Chinese officials in Baotou, for example, they say, yes, we have an issue. Yes, we are fighting against that. We consolidate that rare earth industry in the 6 groups, but we still have to live with that issue that there will be rare earth in that market. And we can discuss about the share.
Okay.
Nobody really knows. This is what is assumed in the market by the market participants. And I guess maybe it's not 50% if it's only 35% or 40%. Each percent is too much. So therefore, this is a big issue because everybody knows illegal mining means that the sustainability is not given here.
Okay, great. Well, thank you very much, Reinhold, for that exposition. We're going to move on now to our next speaker. I hope you can stay online because we will have questions.
Sure,
as
I
well.
will stay online, sure.
Okay, wonderful. Our next panelist is Simon Mohs, who's Managing Director of Benchmark Mineral Intelligence based in London. And he's a specialist, particularly in the lithium sector, but he's more broadly acquainted as well with rare metals. So over to you, Simon. Thank you.
Thank you very much. I left my notes over there, but I'm just going to freestyle it because we're purposes of time. I'd first like to thank Sasakawa and David for inviting me and putting this event on. I think it's really interesting for us, certainly from my perspective. I've covered these niche minerals, kind of minerals that no one cared about back in 2006 when I started. And really, if it wasn't for the rare earth spike, people still wouldn't care about them. But not to say that rare earths and certainly other minerals are definitely due discussion and focus. The one thing we do at Benchmark is we collect price data. So we do price assessments to a methodology for lithium and for graphite, specifically for the lithium-ion battery industry, and we're getting into cobalt. And the reason we set this up 3 years ago was there was a need for it. I saw, it was really interesting hearing the discussion earlier about the supply side and prices, and no one knows prices. Well, it's true, there isn't one lithium price, there's many. There isn't one graphite price, there's many. It's a price range every month, but we certainly try to provide this to give some transparency to the industry and to give the producers and the buyers something to work from. So we look a lot at price curves, and I'll get onto the demands part in a second, but if the rare earth price didn't go up 1,000%, 2,000%, whatever element you could pick, they all rocketed. We wouldn't be discussing it, but it's happened in lithium twice. It's happened in graphite once. It's happened in cobalt once. It's happened in vanadium twice. It's happened in frac sand once massively. It's happened in potash. You can list all these kind of really niche, that sound niche minerals, and they've all gone through a various price spike, all in the last, really since 2009. Let's say 2007 with vanadium included. And the question is, why have these prices spiked? You can simplify them to 2 reasons. There's a supply side. Rare earths is a perfect example of that. Politics, it was because of the industry structure with nearly all of it, 95% at the time coming from China. So it was a really extreme price spike. Lithium, on the other hand, is a demand story. So the reason lithium spiked 50% in 2010 and then 400% in 2015, 16 was because of demand, was because it's a balanced industry from where lithium comes from, but the demand, the emergence of the lithium-ion battery industry forces price spike. And so I think from that perspective on the demand story, I guess that's where we're heading on this panel.
I see. Okay, fantastic. And in terms of if we were to look at these scenarios, you've talked about sort of retrospective. In terms of modeling, what are some of the mechanisms that you feel are preferable and the variables we should consider looking into the future?
Just to pick out which minerals and elements to kind of look for. From my perspective, it's interesting listening to Siemens actually on the rare earth space, because obviously rare earths are very, very important to that specific end user. And most of these minerals are end user specific. They're driven by the end markets. But from Benchmark's perspective, certainly specializing in lithium-ion batteries, we look at hyper-growth industries. where are the big industries of tomorrow? Electric vehicles and energy storage are all rounding on batteries, cheap, abundant lithium-ion batteries. So this is kind of how we, the direction we're heading with Benchmark is that, all right, you've got batteries, but then what are batteries made of? A cathode and anode. All right, but what is a cathode and anode made of? Cathode, lithium, graphite, cobalt, nickel. The anode is graphite, but what type of graphite? And then it's not even any graphite that can be used in it. It's specific coated spherical graphite. It gets really, really specialist. And so that's kind of how we would focus.
So in terms of, we're going to open it up to the floor for questions now, but just to give you an anecdote in terms of demand and hidden demand, going back to David's slide, what I was going to refer to, my current employer, University of Delaware, was actually quite involved in the development of the touchscreen technologies, and there was a PhD student at the time, Wayne Westerman, his name was, and he and a professor there, they developed this technology, and then they made it into a company, Fingerworks at the time. Now, this is the interesting part in terms of demand drive then, is that, there were a few articles written about, this was 1996, 97 originally. And then, of course, Steve Jobs had the insight. There was no clear demand for this out there. People were happy with their Blackberries generally, and other things were going on. They actually liked to see the ABCD probably. But then, you were able to create this innovation, a disruptive innovation, which came out of another interesting aspect is that the research that was supported at Delaware was from a National Science Foundation grant. So it was clearly a government-funded project, which the government had really no interest in commercializing it at the time. It was pure research. And then it went into an area where a whole demand sector was created. So I think that's a very interesting aspect of this, which we should consider also. And this is what Mariana Mazzucato, some of you may know, the economist at Sussex, she is called the entrepreneurial state. That demand is often created by innovation coming from all these areas, and how to project that demand is very difficult. And then when you go deep into the kind of materials which go into that demand. So I'll frame that, I'll leave that for you to think about as a kind of fire starter, and I hope many of you will engage now in questions. Yes, please.
My name is Ron Rose. I work for a company called Ocean Minerals, and we're developing a deep water scandium resource, but we're probably a decade out. We've got the same kind of issue on this demand thing. We've got companies like Scandium International, George Putnam down at the other end there, that they are trying to get a scandium mine in Australia up and going in a couple of years. But we, as a group, have this problem of how do you say demand when demand for scandium is 10 tons a year, 20 tons a year right now? George's company will produce 30 to 40 tons a year. We will produce 200 tons a year. But how do you define that price? Now, Siemens is progressive here in saying that they will support young blossoming mining companies doing this, but they're going to incur a higher cost than some of these other people that use the same elements. So how come Siemens has to take the brunt of the R&D and the support where other companies are riding the coattails? Reinhold, would you care to answer that?
Okay, very good. Thank you.
That's a very good question. So you just mentioned regarding the price, how to define the price. This is really a very, very big issue because we have a similar issue with the lutetium. With the lutetium, there is a current annual production with roughly, let's say 80 tons to 100 tons. And there's three big players in the market. It's General Electric, it's Philips, and it's Siemens. We are the main customers. I assume we are consuming probably 80% of the global production. So therefore, if we, and this is an experience, if we try to bundle that demand and to ask the suppliers to give us a quote, you can see immediately the price jump up and to levels you cannot afford that. Therefore, we are aware of that, and therefore, and this is not a secret, we do a kind of, well, I call it silent buying. So this silent buying means small shares, small quantities, not to make you too attractive for governments or for the Chinese. You know, if they identify you and your demand, they know they can catch you, and we will not sit any longer in the driver's seat. And therefore, we take this very serious. And I cannot tell you the number of how much material we stockpile, but it's not just 1 month. So if there is any decision that we do not get any material at suitable pricing, we have enough material to change technology. So maybe this answers your question by half. So if you ask me for a recommendation, I would look for an alignment with one of the manufacturers, maybe with one of the Scandium mines, and maybe you do that jointly with partners. So we are discussing similar partnerships with companies, not like Siemens, but which could enrich our basket.
Indeed. But with Scandium, you know, because that mine is in Queensland, they want to develop one of the mines. I'm familiar with that case. The issue is also like the future demand for the solid state fuel cells and all. Again, you know, forecasting that is tricky. So if you can make a case that, wow, that's really going to happen, then you get, I know the Queensland government really wants that mine to happen, but they need to be able to make that case if they're going to subsidize it in some form. So, okay, very good. Other questions? Yes, please. Sir. And please do introduce yourselves.
Yes, I'm Preston Bryant with Momentum Technologies, and we've been working with the Critical Materials Institute to recycle permanent magnets. And I've had a really hard time now that we've developed the process, finding someone to buy it from me. Would you be the person I would talk to after this?
You're addressing this question to me. So, yeah, if your price is reasonable, we will connect.
So
yeah, we will connect you. We will connect you with that material with one of our magnet makers, because I did not mention before we have two kinds of approach. We have approach with oxide. We directly buy because we are using that oxide for crystal growth at our companies, and we have the second tier material. Therefore, it's a very good question, and we discussed the second tier material price with the producers, and we forward a kind of transfer price to the magnet makers. So therefore, yes, I'm the right person to discuss with, and it sounds quite interesting how you see your opportunities.
Look forward to talking to you soon.
Thank you.
So maybe
Thank you. So please contact me.
The broader question, I think, around recycling, maybe if our panelists can also comment on that, because currently, you know, often people, when I mention recycling, they say, look, the percentage of rare metals in the cell phone is less than in the ore, so why would we mine it from the ore? And, you know, all those kinds of arguments. Could you comment on, like, what's the prospect for the recycling sector?
Well, that depends on the price. Yeah, that's it is. I think that in the future the price of the rare earth element will go up higher. So I think that well, someday, but I do not say the date correctly, concretely, but the recycling will be feasible. And as I introduced you, in the case of the magnet, the prices, most of the prices are the dismantling price. So the automated dismantling process is discovered. So it may be feasible.
Well, and that raises an important point about designing. You know, I was a student, I had the honor of being a student of Tom Gradle in industrial ecology, and one of the first things we learned was design for environment. You design the product in a better way, in a modular way, you know. So you had this fair phone phenomenon. I don't know if you heard of that. There was this phone that was designed so it could be better recycled in more modular form, smartphone. Is that something that, you know, companies need to think about? And I should, for full disclosure, mention Reinhold. I worked for your competitor, General Electric, many moons ago. And at the time, you know, when we had the new CEO, Jeff Immelt, came in, he came up with the Eco-Imagination logo, basically saying that the company should be, you know, designing things in that way. It's not just about green technologies, but the whole design. So is that something we should all think about? Yeah, a follow-up or a quick follow-up, or should we go, maybe quick response from Reinhold and then we can go back.
Okay.
Yes, go ahead.
I know this is a topic, and I know also from our competitors in Japan, they are designing, for example, the motors to reduce the efforts for recycling. I know that, but we also know, or this is one of the latest information I got, this recycling from that motors to take out the magnets is not actively done today. And if you take, for example, the automotive business, who will finally take out the small magnet pieces, 6 grams, 10 grams, 12 grams, out before you put the car into the furnace? So nobody will. So therefore, I think it's important to discuss that kind of urban recycling and how to do that, because finally, if we burn the material, if we burn the rare earth in converters, the material is gone forever. So therefore, I think it's worthwhile, but there is a big but. We discuss somebody has to pay for it.
Yes. Yeah. Okay. Thank you very much. Quick point.
Yeah, I agree with that point. It's recycling is always going to be. It's not going to be industry that really spearheads this, or someone like a big company, because unless they've got a real supply problem for rare earths, they're not going to put all the effort into recycling, because what's the point? I mean, with lithium-ion batteries, for example, recycling is happening only because governments are saying you've got to dispose of the batteries, not because there's a lithium supply problem long term, or getting the graphite out. Some cobalt is recycled out of it, but that isn't because there's a supply situation, an industry situation. It's because governments are saying you've got to do it.
Yeah, but government, yeah, exactly. So governments can be a driver with European Union directives and so on. Yes, please, there, and then we can come back. Yes.
My name is Ann Bridges, and I've been in Silicon Valley for about 40 years now. I authored a fictional account of rare earth called Rare Metal. And in the process, many people have asked me, where is Silicon Valley on this? Where are the investors? Where are the VCs? And I asked a question to you because it seems to me that what you're talking about a lot is bounding risk. The VCs at this point don't know where to invest because the product life cycles are happening so fast. They have morphed from silicon and hardware into software and services. Their focus is liquidity events, not necessarily long-term investments, and you just have a huge gap between the product life cycle that exists today and the requirements of mining. Apple, interestingly, is a self-contained community. They did their own hardware, software, and they're the ones who came up with this. In the PC industry, when that first started, the only time it really took off was when there was a compatibility of components, where everyone could be very sure that if they were developing one component, it could go into every single PC. And it seems to me that much of what you're talking about is Siemens is going to develop something for their specific use, and then the Tesla is going to develop something for its use, et cetera. And you don't have any kind of commonality of purpose, and therefore you don't have shared resources. And you're not going to get the kind of investment you all want or the miners need until there is some sort of cohesive plan. And I don't know whether that's going to come from the government, whether it's going to come from people like you and conferences like this, but to me that is the huge gap and why there is such disinterest. I don't know who else is in here from Silicon Valley specifically, but I bet there aren't many.
Yeah, okay, very good question. And it also ties in with the question of intellectual property and, the broader secrecy in that regard too. Why, how do you get people to collaborate when all the incentives are for them not to?
And it's also a question of how niche the market is. So rare earths is a very niche market, I didn't see the figures earlier, 120,000 tons a year. Maybe 130. Lithium is 160,000 tons a year of chemical. These aren't commodity-sized industries in the millions of tons. Now the question is, are they going to grow or morph into something like that over the next 10 years? Now something like lithium, for example, will do, we believe, because of the size of the industry and what's happening with electric vehicles. That then will change the way companies, the big companies, will operate, and a form of standardization we expect will start to creep in the industry, but that's a function of size. We don't think, if the industries remain niche, why would Siemens want to give away the spec of rare earth elements that they buy and put into their products? It's an IP thing, and I think end users have to be forced down that route, and more players have to come into the space for that to happen. And
well, one point I should raise in terms of international governance, there are a few entities that are there, like Tom is involved with the International Resources Panel, which is an international group essentially under the United Nations Environment Program that is coordinating conversations between researchers and industry and governments. There's the Global Future Council on Advanced Materials that John and I are members of, which just convened for the first time 2 months ago, where we had one of the heads of research at IBM, as well as people from governments and academics, trying to say how can we actually come up with a planning process around this. So there's a tentative effort around it, but it's still very embryonic. So yes, please, you. Either one. Well, actually, yes, first there, and then, yep, thank you. And then we'll come back. Those who haven't spoken yet, we're giving them first.
Good morning. I'm Anthony Marchesi from Texas Mineral Resources. We're developing a heavy rare earth mine in Texas, as well as doing some work extracting rare earth elements from coal overburdens in the Pennsylvania area.
Okay.
I've had a conversation with many of the supply chain managers in the Fortune 100. I can tell you, to Reinhold's credit, there are very few that I know of that are like Reinhold. I believe, as a comment, the biggest problem we have is that most purchasing managers, at least in the United States, have no idea where their raw materials are coming from. By and large, they're assemblers, not manufacturers. So when you're an assembler, for the most part, there's no extra money. There's no extra bonus if you source a raw material from the United States, or if you secure a supply or stockpile. There's absolutely no benefit. Their bonus is if they can produce on time and at or under budget. So in my opinion, the biggest problem the United States has is complete ignorance of the supply chain management.
Okay, good comment. What I'll do is I will go around and do a round of questions or comments, and then we'll just do the finishing with the panel because the clock is ticking. So yes, sir, you've had your hand up for a while.
Just to follow up on it real quick and philosophize of how to upend the monopoly, Chinese monopoly all the time. To an idea, we can use technology to upend this model. If we can create, like, let's say 3D printing with the magnet that has just come up recently. If we can drive down those manufacturing costs, we can afford to pay more here in America to produce our materials. We can fix this model, at least in the short term. That's obviously not a long-term solution, but it can get the wheels in motion.
That was one of our main focal points at the discussions in Dubai, was 3D printing will change the world. And yes, yes, please, yes, go ahead. Yes, thank you.
My name is Tim Mulch, and I'm associated with Barry Dolbear as well as my own firm, TAA Advisory. My question is to Reinhold. I found it very interesting that you did indicate that your company, as a result of this exercise of from top down to understand the sources of your materials and where they are in each of your products, in the process, did you also make decisions, and of course I realize it's quite sensitive, beyond lutetium into other materials that also apparently have choke points at which your company is dependent upon, and therefore are stockpiling maybe even what ordinarily people wouldn't think of as being materials to stockpile?
Okay, thank you.
And if you could comment on that, I appreciate it.
Great, thank you. Any other last minute questions before we go back to the panel? Yes, one please. Yes, sir. Please over there.
My name's Alex Canara. My name is Alex Canara. I'm with Thorium Energy Alliance and Citizens for Green Nuclear Power out of San Luis Obispo. I have a question for Reinhold. Given that you mentioned that, excuse me, the 3 megawatt Siemens windmill consumes about a ton, that's a metric ton, I assume, of rare earth
2 metric tons.
2 metric tons. Okay.
2 metric tons, 3 megawatt.
Good. Thanks. I'm glad for that. So when we see one burning in the Netherlands or Germany, and it falls down, and the fire engines come and put the fire out, what happens to the magnet? The 2 tons of magnet? Does it get recycled? I mean, I'm very glad to hear about all this recycling effort and interest, and from the design standpoint, what's actually happening today with regard to all the various materials, like the windmill magnets, that are in relatively large mass per unit. What's happening
And related to that, maybe the residence time of the magnets. So we don't know, like, how long does a wind turbine last? We don't quite know exactly.
We have ideas about how long
20 years.
gearboxes,
Yeah, so
20
we'll
years
go
or
to
so, yeah.
Maybe, yes, Reinhold, we'll go to
20
you
years.
first for responses to those, and then we'll wrap up with the rest. Yep.
So how long do you think?
So to answer your question, please could you repeat?
Yeah, the question is basically how much of, let's say, failed this wind turbine example. I'm just using it because we know you say how much is used in it. How much of that is actually recycled?
So just to give you a rough picture, if our demand is at 1,500 or 2,000 tons a year, so the recycle share is roughly at 1%.
Oh, okay.
Yep.
Thanks.
But you see, that is why I was saying, because it's a new technology, it's going to be there for a while, and then at some point there's going to be obsolescence, and then it comes back. So it's recycling is hard. The percentage in recycling, again, be careful when you see these numbers and percentages. When I teach my students, often is one of my pet peeves is the percentages are very misleading. But yes, please. There was one question also for you, Reinhold, from colleague here on stockpiles. Yes. Yes, go ahead.
So can you hear me?
Yes. Yep. Good.
Okay, so for the stockpile material, please can you repeat your question again in short?
What determines the levels that you're maintaining of stockpiles in the case of lutetium, and then also are you now, as a result of this exercise, creating more stockpiles of other things that you come to realize are sensitive in supply?
Okay, depending on the accessibility of the material. So just to give you one example, heavy rare earth, you nearly have no chance to get this outside of China. So this is very clear focus of stockpiling. With the light rare earth for the magnets, we can deal with Linus. There is an option outside of China. There are other options which can arise in the next couple of years. But for the stockpiling, heavy rare earth is clear in the focus.
Okay, thank you. All right, very good. Well, for the panelists, if there are any closing comments based on some of the points that were raised, or any take-home messages which you'd like to share?
Yeah, as a public sector, we not limited to the rare earth problem, but general industrial technology development. Our role is to grow the seed of new technologies to the level of actual production. So for that purpose, we are continuing our efforts to for the research to grow the research project and others. So.
Okay, very good. So the part, you know, I have been often surprised by how, and that is one of my areas of interest, is conflict resolution, peace building in the resources sector. So I wouldn't be surprised how things may change there too. So
Maybe.
Thank you.
Yeah,
Closing comments or responses?
I just wanted to pick up on it was interesting that purchasing manager not knowing the supply chains, and it's really true. It's a really good comment about the purchasing guys not knowing. But the point is, very few people know the entire supply chain, and I'm talking about from mine to market, and everything in the middle. So all these elements we're talking about are more akin to chemical processing than they are mining. So understanding every part of it is absolutely critical, and hardly anyone does. And there was a great case, a perfect example, was about 2 years ago now, when Tesla announced their Gigafactory. They put out a press release saying they were going to source all their battery raw materials in North America. That was in a response to a Bloomberg article saying that graphite makes dirty rain in China. Then they realized there's only one tiny lithium mine in Nevada, there's only one tiny graphite mine which doesn't make battery grade in Quebec, and there's no cobalt mine in North America. So they haven't got a choice. So I think that kind of sums up, knowing your supply chains is absolutely critical, and hardly anyone does.
Yep, and indeed, and that goes back to the point about, you know, saber rattling and geopolitics around particular countries. One has to be very cautious about when you don't know what is out there, and that's why, I mean, look at South Korea and China have made a bit of a pragmatic alliance of late recently, which, you know, they have similar grievances historically as Japan and China.
And incidentally, Tesla have a team of 5 people now looking at 3 minerals, or 4 minerals really. Yeah. So that's pretty good. That's kind of what we do.
Yep, indeed. Okay, very good. So I think this has been a very fruitful discussion in terms of the scope and breadth of the conversation, and we really appreciate Reinhold connecting late in the evening from Germany. I hope that you will follow the work of this conference. I'm sure David and colleagues will be briefing you further about output. Thanks to the panelists. It's been, for me, a great learning experience, and I look forward to further conversations. So I think we have a video message now transitioning off. So thanks again, everyone.
Thank you. It's my pleasure.